Pythagorean Theorem, huh? All right, well, why are we doing it now? Well, because Pythagorean Theorem can only be used in a right triangle, and everything we talk about this unit is for a right triangle specifically. And by the end of the period, I'm going to give you 3 side lengths of a triangle, and just knowing the sides, you're going to tell me if it's an acute or obtuse. What do you usually need to see if it's acute or obtuse? Angles. Well, you're not going to need them today because of Pythagorean theorem. Okay, so that's the goal by the end of today. Quick review here. We know Pythagorean theorem is a squared plus b squared equals a little c squared, right? What is c? Hypotenuse, up. And if you're ever concerned, where's the hypotenuse always located? Across from the right angle. Doesn't matter how the triangle's turned or flipped, it's always across from the right angle. And then how about A and B? Legs, yep. So we're going to use Pythagorean theorem in a couple different ways today. Welcome back, parallelogram, huh? Welcome back. It's been a couple weeks. Welcome back. Perimeter. I'm not going to assume this because I was teaching my senior class earlier in the week, and I asked somebody about perimeter, and they're like, "Oh, length times width," and then I almost had a heart attack. So, perimeter, anybody? Perimeter. All the sides added up. Do you guys know any sides yet? 9? 9? I believe the 9 is from the height, the altitude to the one vertice. Ow! Ow! Is that what those double bars mean? Yeah, it does. So how long is one side? 11. And since you know you're awesome with your parallelogram properties, the opposite side is 11. Nice job, kids. The only thing I need to know is the other pair of opposite sides. How can I find the length of the other pair? Here we go. One use of Pythag right here. I just need somebody's help here. What are my values here for Pythag? Oh, 2. Here we go. Well, where? Okay. Getting 40 equal to c squared. Are you guys becoming more comfortable breaking down these radicals? I feel like seems like last couple units we've been doing it a ton. All right, so break down 40 for me. Eight. Two radical 10. Here we go, perimeter now. Here we go, one side. 11, second side. 11, third side. 2 radical 10, fourth side. 2 radical 10. All right, another quick review lesson in radicals. You cannot combine all 4. You cannot combine all 4. You can combine maybe a couple pairs, but not all 4. What do you think you can combine? 11 and 11. Absolutely. 4, 22. Think you can combine 2 radical 10 and 2 radical 10? Okay, yes, you can. 4 radical 10. As long as what's underneath is the same, you can combine them. Okay, you can combine them. And that's it, but we're missing something. It's naked. Units, which are feet. In an honors class, if the problem has units, so do you. All good. Little radical review there. All right, number 2. First, before we start number 2, this is a big moment in your honors geometry career right now. Your first introduction to Big Al. All right, to Big Al. He will make an appearance in your notes, quizzes, and tests for the remainder of the year. He is a legend in Honors Geometry BC. Talk to anybody who has taken this course before and just say Big Al, they will know exactly who you are talking about. His actual, what he looks like, his appearance will not be revealed until the final unit of the year. So you will be kept in suspense to, what does Big Al really look like? End of the year, you'll find out, okay? So here's Big Al. He wants to go from point A to B, but he's got a pond in his way. So to avoid the pond, he's going to go 34 meters south, 41 east. How many meters could he have saved by just walking through the pond if he could? All right, don't want to walk through the pond, might get wet, might drown, go to the other extreme. 34 meters south. Oh, and this is where I start getting kids nervous. 41 meters east. They still teach you never eat soggy wheat. East. So we went 34 meters to the south, 41 meters to the east. Well, right now, when he did that, how many meters has he walked? So right now he's walked 75. But if he went through the pond, how many meters could he have saved? So we need to find the length of the hypotenuse, the pond, right? Okay, can you give me where 34 and 41 should go? 5?
They should go as A and B.
Thank you. And there's another thing we need to discuss, which we have not all year because it hasn't come up until right now. Guys, when I find the length of the pond, am I officially done with the problem? Let me ask that again. When I find the length of the pond, am I officially done with the problem? No, I am not. Why do I keep asking you guys that? Because this number you are getting in your calculator, the square root of 2837, is not ready to be rounded yet. We do not round a darn thing in here until we are at the final answer and ready to circle it. Nothing gets rounded until then. So yes, I am asking you guys to write out 53 point, stretch out your wrist, go get an ice pack if it hurts. All right, suck it up. 49,594. Do not round anything. And the reason, it's just not like, you're an honor, so you shouldn't. It's because, anybody know why you don't round anything to the end? If you round this a certain way, maybe, it could throw off your final answer by 1 or 2 units. Okay, that's why you keep everything. All right, so how do I find how many meters saved? I got the lake. I got how many he went. Here we go, 20. Find me how many are saved. What's that? Okay, how? What numbers am I using here? Yep, he went 75, but the lake was 53.26. Yep. Right there, and you guys can do that. I'm okay with that. I get it. You don't want to write it over. But everyone knows in your calculator, you can just, how many of you can just copy paste it in? And if you can't copy paste it in, that's, hey, you guys that can't copy paste it in for whatever reason, everyone see above your negative button, you have ANS, which stands for answer. If you do second negative, your calculator will plug in automatically whatever your previous answer was. Okay, so it doesn't matter if you can copy or paste or not. All right, so that's a nice little trick to remember on your calculator. So rounding to the nearest tenth of a meter here. Big Al could have saved 14. 14? Tenth, 0.7 meters. There you go, Big Al. You could walk on water. You guys all good? You ready to show off some algebra? Oh yeah, you ready to show off your algebra skills? Let's do it. What type of triangle? Right triangle. I know all three sides. That automatically means to me little Pythag. Oh, I don't want to reveal that yet. All right, fill it. Can I please have it filled in? 11, you're up. Fill that bad boy in for me. Good talk right there. Equals. Okay. And I get it. 64. And then I don't know. I get really freaked out now. What you are going to do here. Ooh. We're not doing x squared plus 16, x squared minus 16. Get that garbage off your paper. Come on, you're better than that. What am I asking you to do when you square something? Multiply it by itself. FOIL, double distribute. What algebra did you learn last year if you're taking and distributing that 2 as an exponent? All right, I'll let you go on your own because I want a lot of you to panic when something happens here in a couple lines. I want to see how you're going to resolve that problem you're going to have. Watch what happens and how you're going to get over the mountain. X squared minus 8x plus 16 when you FOIL, double distribute. Cleaning it up, you get x squared minus 8x plus 80 equals x squared. Everybody's good. Oh, and then what happens? You want to move everything over, but they're gone. What do I do now? Okay, great. It canceled out over here. You're still left with what number here? 0. Get x by itself. Don't make it more complicated. There's no factoring. There's no quadratic formula. How do I get x by itself? Okay, I could do a couple things, I guess. Move 80 over, divide by -8, x equals 10. We okay there? That's because that'll come up again tonight. All good. All right, now another use of Pythagorean theorem. Now we'll get into that. Is a triangle acute or obtuse business? All right, you don't have to write this down. I just want to basically summarize what these theorems are saying. So we know a squared, b squared, and we got c squared in the Pythagorean theorem. Okay, you're going to have 3 sides of a triangle that you're going to plug in. The 2 smaller sides will get plugged in for what? A and B, and the biggest side, the biggest side, I'm not going to call it the hypotenuse because it might not be a right triangle, but the biggest side is going to get plugged in for Okay, and then you're going to crunch those numbers. And if a squared plus b squared, the legs end up being bigger than the hypotenuse, you have yourself an acute triangle. Okay, if the legs are bigger. If the reverse is true, you plug in the two smaller sides and they happen to be less than the hypotenuse, we're going to have ourselves an obtuse triangle. So everybody good so far? The only condition I'm missing is what? I got greater than, I got less than, equal to. That's what you've been doing all your life, right? When does Pythagorean theorem only work? In a right triangle. So if they're equal, it's a right triangle. So everyone have the different scenarios. Not bad because I know you guys don't care, but I do. That's pretty cool because you don't even need to know what the angle measures are now. I can just need the sides and plug it into Pythag. Here we go. A, 9, 12, 15. What type of triangle do I have? Well, two smaller sides. I'm going to say 9 squared plus 12 squared. I'm not going to put equals. I'm just going to say, hey, how does that compare to 15 squared? I'm going to see which side is bigger. Maybe they're equal. So 9 squared and 12 squared, how does that compare to 15 squared? Okay, let's go here. 18. What did the 9 squared, 12 squared side come out to be? 225. How about the 15 squared side? Oh, look what happened. They're equal to each other. So if they're equal, 9, 12, 15 are sides of a right triangle. Yep. 10, 11, 13. So take the two smaller sides, 10 squared, 11 squared. How does it compare to 13 squared? Let's find out. $16. Here we go. 10 squared, 11 squared side. 13 squared. So it looks like the legs came out to be bigger, which means it's an acute. Don't turn your page. It's a Friday afternoon. Little snow later on. How about I challenge you right now with a part C? What are you doing? What are you doing? What are you doing?
It's not possible.
Why are we even testing if it's acute, right, or obtuse?
If you had science,
It's not even a triangle. Why not? Come on, dig deep. Little review. Got him. Got him. Why isn't this a triangle? Sum of two sides needs to be? What's the problem? Correct. 6 plus 8, not bigger than 19. This is not a triangle. Watch out for that. I'm doing that because it will occur tonight on homework. Okay? I know that for a fact. Okay? So watch out. You got to make sure it fits into sum of two sides bigger than the third. All right, good. Look what's back. Graphing. We know what's coming up then. Yes. A little graphing one. Is it acute, right, or obtuse, this triangle? Well, it looks like, no. This isn't the look like game. What are we going to have to find to see if it's acute, obtuse, or, because I can't do angles. I got to find the side length, so we'll do distances. Can we break this off? We'll break this off here. All right, group, who's group 1? This side here? Everybody, huh? Okay, group 1 here. Riley, what side you want for your group? Big decision. XZ. Okay, group 1, you got XZ. Who's group 2? Group 2? Jack, go ahead. For the ladies, what do you need? What side you want? XY. And then group 3, sorry, no choice for you today, ZY. Just find your side, please. Let's go. 17. 17? Which one were you responsible for, Patrick? ZY, what do you got? 2 radical. Which one is it? Breaking down 20. Good. 2 radical 5. ZY. Good job. Let's see if I can do this. 9? Yes, here we go. Which one are you responsible for, Riley? XZ, what do you have? Radical 13. Nice job. All right, here we go. Can he do it? Get somebody from group 2. Who is group 2? I only got 5 numbers to choose. Ooh, boy. 11? 10? 9? 15? 6? Hey, there we go. XY. Radical 29. Okay, first thing we need to check, because we got cooked last problem. Is it even a triangle? So what are the 2 smallest sides up here? That's the first thing we got to determine. Radical 13 and 2 radical 5. If I add those together, let's first check if it's a triangle. If I add radical 13 and 2 radical 5, is it going to be bigger than 2 radical 29? Let's first check that on your calculator, everybody. Is radical 13 plus 2 radical 5 bigger than radical 29? Yes, it is. Okay, so it's a triangle. Now let's test what type it is. Radical 13 squared plus, what's the other smaller side? Did we learn anything yesterday when we do this? 2 radical 5 in parentheses squared. Compare it to the larger side, radical 29 squared. Let's see how they compare. Okay. Whew. 3. The radical 13 and the 2 radical 5 side comes out to be 33. I will give you props for that, Emma. Not because you can use your calculator, because seriously, this is my 3rd time doing this. Both periods before gave me 23 because they can't add. Okay, because they can't add. And then radical 29 squared is 29. What was bigger, the legs or the hypotenuse? Legs. So if the legs are bigger, this is an acute triangle. Okay, acute. And then we just got one more. This next one is an old Regents question, except we changed the names. Big Al, once again, says that these two triangles are congruent. Little Mike, aka his brother, says that the two triangles are similar. Are they both correct? Nobody's correct. One and not the other. You have, I'll give you about 4 minutes with your group. Go ahead. So first start with, are they congruent? Yes or no? And be able to tell me why. We've been here 20 plus weeks now. You should be able to tell me why two triangles are congruent. And then are they similar? And if you think they are, we just did a unit on similar triangles. So you should be able to tell me why they're similar if you think they are. 4 minutes. Do this again. 7, are they congruent? Okay, I'm ready. Okay, side, 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 but I just have one side. Oh, Pythag, Ellis says what? Good, and for the second one? 12, perfect. So, yes, they are congruent by side, side, side. Now, I always like to challenge you guys. What could have you also had instead of side, side, side? Side, angle, side. Go deeper. No? Charlie? HL, because these are what type of triangles, young one? Right triangles. HL, good. We could have HL. Are they similar? Two? Yes, they are similar. What's your reasoning? What's ratio 1 to 1? Triangles can be in a ratio of 1 to 1. Sides are in a ratio of 1 to 1. So basically, what method are you using from last unit? Kid finally knows something, and he's like, oh, I'm doing this one. I don't care if my number's up or not. By side, side, side. I could have also used what instead of side, side, side? Similarity. Side, angle, side, similarity. Nice job today, guys. Nice job.